Hello, Holy Wiremod here. Welcome to tutorial 15 in the GLua Pro series, where we're going to be taking a look at object-oriented programming as well as inheritance. So let's start by going to the wiki, which has some very good examples on object-oriented programming. Now, it goes over two different methods. One is via modules, and the other method is going to be via metatables, which is our most recent tutorial. So that's the method I'm going to stick with. However, we're not going to be using this method, as I'd like for you to have additional examples to look at so you can understand object-oriented programming a little bit better. So first off, you have to understand what an object is. So an object in programming is going to be a collection of data which is organized and structured in a specific manner, and it's going to be derived from a class. A class is listed on the left-hand side right here. So we have weapons, we have NPCs, entities, files, vectors, and all these other things, which we're going to have future tutorials on now that we have the basic understanding or foundation of an object and a class. Now, a class can be derived from a base class. Now, the base class is through inheritance will give its properties to the class which is deriving from the base class. So, for example, we have a weapon pistol. Now, the weapon pistol is going to be the object, but that object is based off the weapon class. The weapon class, which is based off the anim class, and anim class is going to be based off the entity class, which means that weapon pistol is going to have all the properties. So you have an entity, for example, like position and model, which it gives an example right here, while retaining special properties from the weapon class, such as clip size and damage. So here we have an inheritance hierarchy, which is a very nice example. I really recommend this. I'm going to have a link to this article in the description below so you can look at this as well and go along. So let's go to the notepad and let's clarify what all this means and give a nice example. So we're going to start with our class called food. And this is essentially going to be a metatable where we have initial or default values. And so name is going to be none if none is specified. We're going to have a default cost of $1 or a pound or whatever, a mark or whatever you want to put in there, that's fine. And then we have a weight of 0.1 pounds. Now, here we're going to have a function, and we're going to have food, new, and this is where we're assigning our metatable to a table here. So we're going to have our name, cost, and weight arguments for the food object that we're going to be creating. And we're going to return self. So what is self? Self is going to refer to food, which is left of this colon. So whatever is left of this colon is going to be what self is referring to. So for example, if we have another function, which we're going to be making anyway, called toString, which is going to find everything of the object. If we're to use self in here, because food is left of the colon here and here, this self is equivalent to this self, which is very nice, which means we can communicate between functions using this method. So let's set a meta table. And we're going to put food as our meta table, of course, as we've defined above. And we're going to have self name equal to name, or assigned to name. And then we're going to have cost is going to be assigned to cost, and weight is also going to be assigned to weight. And of course, this is a table. So that's why there's key values assigned to self, because this is going to be a returning table, which is important for something I'll explain in just a moment after we finish this function down here. So we're going to have string, which is going to be string format, and this is going to tell us information about our object. So let's say we're going to have the name, which is going to cost us, and then we'll have two floating point value for the cents and the cost, and then we're going to have ways, and then we're going to have another floating point value, which is going to give us the pounds. Okay, so now let's define name, which is going to be the %s that you see. And then we're going to have the first floating point, which is going to be cost, and the second floating point, which is going to be pounds or weight. Okay, now we simply return food string, and there we go. Now we have a toString, which describes our object. So let's actually create the object now. So let's go to table copy. So we're using copy because if we use a table, remember self is going to be returned here. So we're going to have a table here. If we have a table assigned to another table, it's going to be the same table that it's referring to. We don't want that. We want to take copies of the table. So we're using copy. And here we're going to be creating a new food object from the food class. Remember, food is a class here. And we're going to call it soup as our name. The cost, and I'm going to put this in string format so you can see that it automatically converts to a number or floating point with the string format. It's very nice. And I'm also going to have an integer here as well just to show you that. And there you go. So now you get a little bit more information about string format, which hopefully is useful to you. So then we're going to have string, and there we go. So we have soup cost $6.95 and weighs 0.7 pounds. Very good. So as you can see, this is automatically converted. Everything works good. Now we have our object and we have our class. Now let's use inheritance, and this is going to be our base class for our new class. So we're going to create the new class. The new class is going to be called fruit, which is inheriting from food. Okay? It's very simple. And then we're going to have function fruit new. And all the parameters that we have up here, in fact, I'm just going to copy and paste that, are going to apply to fruit as well. So in addition, though, which makes fruit unique as a class, we're going to have calories. So instead of food, we're going to be putting fruit right here and fruit right here. And likewise, we're going to be modifying this to calories. Okay, so now we have a meta table set to fruit, the class, and then we have our table, and we're returning our table. And likewise, we're going to be returning a string which describes the object. Zoom in right there. There we go. And let's put fruit right here. So we have fruit. There we go. Fruit string. And we're going to be tacking on with, and we're going to say 0.1, and we're going to put calories right there. And let's actually put a space and also an F here to indicate that it's floating. Okay, so now let's then tell string formats that we're going to have calories. Substitute there. Actually, you know what? Let's put this as a string so I can show you that you can convert from an integer to a string, just as we did with string to integer in the above example right here. Okay, so now with that, we're going to have our objects, which we're going to define. So we're going to have table copy and fruit. So we're going to use the fruit class to define our new object. And we're going to say banana is the name. It is going to cost $2, and it's going to have a weight of 0.4 pounds with 105 calories. And then we're going to create a company with this one called Apple, and Apple is going to be edible in this case, and then we're going to have it's the new iApple actually, and we're going to have a weight of 0.3 pounds and 95 calories on our iApple. All right, so then we're going to go to banana, go weight, and we're going to print out that. Then we're going to describe our object with the toString function that we created. And we're going to do the same thing with Apple just to show you that they are indeed independent objects. Okay, so here we go. We have banana costs $2 and weighs 0.4 pounds with 105 calories. Apple costs $1.50, weighs 0.3 pounds with 95 calories. So just to emphasize, if we did not put table copy here, it would both be banana, or both be apple in this case, because they are not independent tables. All right, so let's just put that back. Now I want to actually go and get a procedural version of this really quick, and we'll compare procedural to object-oriented programming. So I happen to have one, just like a cooking show, pre-made for you. And we're going to just paste this in and save. And as you can see, it does the same exact thing with the procedural version. So here, if you want to pause and just look over the code, we have our table, which is going to pretty much be like our object, or it's going to be like our class. So our class is soup. So we have fruits class, for example. We have our soup object, our banana object, and our apple object as such. And we have a toString method. Instead of self, we're putting the foods table with two key values, which are going to be the arguments of this function. And we're going to be defining what food item and group that we're getting right here as we print out the weight and the toString function. So if I want to change this to fruits, and then I want to grab from fruits, I want to grab apple, and I print that, there we go, and we have the same string. So what's different between the two, and which one should you use? Well, with object-oriented programming, the first thing you probably notice is that toString has arguments now. So with object-oriented programming, you actually reduce the number of arguments that you need for your functions, which is pretty nice, as well as it's very organized and structured. You notice that all I have to do is copy a new line, and then I create a new object as such from the derived class, which is fruit, which is very nice. So it's structured, you have less arguments in your functions. Those are two very good benefits. What about with procedural? What is advantageous about that is you're actually getting a lot more optimization and efficiency, because Lua is not an object-oriented language. So this, using key values, is going to run a lot faster and a lot smoother. I don't want to say a lot, but the more objects you have, the faster it's going to run in comparison to object-oriented programming than the OOP method. So it's really up to you what method you want to use. If you're looking for structure, if you're looking for less complexity, go object-oriented programming. If you're looking for efficiency, the fastest, smoothest possible running code that you can do, go procedural. And actually, I prefer procedural for my game modes. And anyway, that's a personal preference. If you have any questions about that, of course, you can refer to the wiki, like I said, for more examples for the module method and another example on the metatable method. And of course, you can leave comments in the comment section below. That's fun too. If you like the content, feel free to like, subscribe, share, and bell. And we will get into more fun examples for entities and all this other data types as well in our future videos. And thank you for watching. I hope you have a great day, and I'll catch you guys in the next video. Don't forget to check out Hexane Networks for affordable and high-performance server hosting. That's Hexane Networks, whose link is in the description below.